Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called The Crown of Lucifer. Apologies, I don't remember who actually created the puzzle, and this name is not in the actual puzzle, and it's by Tonatello 86. Anyways, let's get to the rules. We have place the digits 1 through 9 once each in every row and column. So this is Latin squares rule set. I believe that's what Latin squares is. I've never actually had a complete definition of what Latin squares is. Sometimes it says something like this, where you need to place 1 through 9 once each in every row and column, but sometimes it has a different definition that people give it. I don't know. I think it's known as Latin squares, but I could be wrong about that. Anyways, let's continue with the rules. We need to fill the grid with two colors, such that both colors make one orthogonally connected region, and there is no 2x2 area that is filled with one color. A dark hole was placed in row 5, column 5, for a secret. So I don't know if the colors include that. So this is yin-yang shading, though. And if we were to have typical yin-yang shading, so assuming that row 5, column 5 is also in some sort of shaded cells or unshaded cells, it's one color or the other, it might not be. It might just be a different color. It might be considered a different color. But this is an example of a valid yin-yang shading, where one color is all orthogonally connected, and the other color is all orthogonally connected. And what does it mean to be orthogonally connected? It means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So, for example, to get from here to this cell, you can go along the edges here and all staying within the blue region. What is not a valid orthogonally connected, what would not be a valid orthogonally connected, or yin-yang shading, I should say, is something like this, right? Because if you were to have a shaded cell here, now these unshaded cells cannot be orthogonally connected because you have to either go through a corner or you have to go through the blue region to get to the other unshaded cells. And same with this, right? This also would not be a valid shading because we have a 2x2 area that is the same color, and we can't have that. That's an example of how yin-yang shading could work. We also need to, the adjacent digits along green lines have a minimum difference of 5. And all even digits on green lines are the same color. All odd digits on green line are the other color. And cells with no line segment can be either color. So these are what I call whisper 5 lines and what other people normally call German whisper lines. I like whisper 5 lines because a setter came up with that name, and I thought it made sense because it was easily extendable, right? You could have whisper 5, whisper 4, whisper 3, whisper 2, whisper 6 lines, whisper 7, all etc. So that's why I call it whisper 5, and know when I say whisper 5, if you're used to the German whisper line, you know that it's the same thing. So, for example, if this were, say, a 3, then this would have to be 8 or 9, because those are the only digits which are 5 or more away from 3. And that's an example of how the whisper 5 lines work. A straight anti-parity line splits this grid exactly in half. Okay, and to do that, yeah, it does not include the black hole. So that's probably why we have that's probably why we have the black hole. So that means 40 cells are in one line, are in one section, and 40 cells are in another section. Um, Lucifer came along and said, "There is no such thing as crossing the line." Out of rage, he pulled the line through the black hole of the grid. Now it is up to the solver to discover where the line goes to show that the digits mirrored across the line have opposite parities. So on one section of this line, we have even digits, and on the other section of this line, we have odd digits. Okay. Cells separated, but that's different from the colors. Okay. Interesting. Um, Cells separated by a gray dot are either contain consecutive digits or digits in a 1-to-2 ratio, and gray dots lie on the borders of the two different colors, which are different from the anti-parity line. So remember, the colors are yin yang shading. The anti-parity line has to have on one side even digits and on the other side odd digits. Wait, but then that can't split this grid exactly in half, right? If you have, yeah, that's not going to work. You're going to only have 9 times 4 at most even digits, which is 36. And you're going to have huh. Um yeah, I'm kind of confused by this. Anyways, on a gray line, if this were to be, say, a 3, that would mean these digits have to be either 2, 4, or 6 to be either consecutive with it or in a 1-to-2 ratio with it. And gray line dots lie on the border of the two different colors. So there's quite a few rules here. Anyways, that's an example of how the gray dots work. We have digits in cages do not repeat. So there are no repeats within cages either. So you could not have, for example, a 6 here and a 6 here, because in this cage you can't have repeats. Let me see if this clarification if about the line. I'm gonna pause right now to just take a look at what other people say about that rule. I'll be right back. Okay, I'm back. There's nothing that really talks about it, so I don't really understand the anti-parity line. Hold on, I'm gonna take a look and see if I can find any other puzzle related to anti-parity line. I'll be right back. Okay, and I'm back. So yeah, an anti-parity line, it seems, it does break the puzzle into basically into on one side you have one parity, and on the other side you have a different parity. Oh. It's not that on one side it's all the same parity. It's that across that anti-parity line, you have to have um, and usually it's along a diagonal. It obviously cannot be along a row or a column, because if it were, then it wouldn't satisfy you could. So the reason why it has to be along a diagonal is that it would basically break the puzzle into one side is one parity. That means the other side has to be an opposite parity. So say this was the anti parity. Oops. Say this was the anti parity line here. Then along this, if this were, say, an even digit, this would have to be an odd digit, because across the anti-parity line, you have to have opposite digits. Now, I don't know if it's guaranteed that it's along a diagonal here, but it can't be just straight along a horizontal or vertical row or column, because if you were to remove those digits from parity, actually, I guess it could kind of work, can it? No, it can't. Because the thing is, everything that would be mirrored across this line, so say we had not across, say we had something like this. Oops. I can't do that. What if we had this? Say this was the anti-parity line. Then everything here would be mirrored across here, right? So if this were odd, this would have to be even. Same with this. If this were even, this would have to be odd, etc., etc. So you'd have 4 evens and 4 odds in each row. But these would then have to be the remaining odd digits, and you cannot have the odd digits essentially be a complete column, right? But it can be a diagonal, because you have to have the digits 1 through 9 in a column, but along a diagonal, there's no restriction of any sort. So I guess what I'm saying is that this line probably is a diagonal. I am not going to make that assumption, but that's very likely the case. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for the coloring, we know this is a boundary, this is a boundary, this is a boundary, this is a boundary. Same with this and this. And here. Okay, and then all of the edge is a boundary. We know the bottom right box has to contain the digits 1 through 9, because there are no repeats in any cages. So we are guaranteed 5 has to be one of these digits along this diagonal. So there has to be a 5 here. Same with this, though this could be any combination of digits from... It has to be 8 out of the 9 digits there. Even cells on a... So... This digit is next to 2 unique digits on a Whisper 5 line. This is also next to 2 unique digits, so this is 1, 2, 3, 7, 8, 9, 1, 2, 3, 7, 8, 9, and this must be 1, 2, 3, 7, 8, 9. Because there's no guarantee that these digits are not the same here. What about this? These are next to 2 unique digits each. So these are also 1, 2, 3, 7, 8, 9. For yin yang shading, if one diagonal is one color and the other diagonal is a different color, sorry, you can't have. So for yin yang shading, if one diagonal is one shade, you cannot have the other diagonal be both the same shade as those, because obviously then that 2x2 area is the same shading, right? So say this was, well, let's make it orange and pink. If we had orange here, these cannot both be orange because the 2x2 then would be all orange. It cannot also be all pink, right? Because if this is pink here, then how do you orthogonally connect the pink regions without breaking the orange regions into multiple regions? And you can't, the answer is you can't. And the same thing goes for the orange region. So if you have one diagonal that is one shade, you know one has to be the opposite shade and one must be the same shade as that. So this has to be orange and this is pink. Therefore, this cannot both be orange. So one must be orange and the other must be pink. Well, this can't be orange because that would force this to be pink because no 2x2 area can be all orange. So therefore, this must be orange, this must be pink, and we have this pink going out this way. Okay. So another thing we know about yin-yang shading is once you change twice, that's the most you can change. You can either change shading 0 times or 2 times. You can never change 4 times or more. You can't change 1 time, obviously, because if you change 1 time, then you have to change another time somewhere here along the edge of yin-yang shading. Right? Because this can't be just all pink here and then not turn back to orange. So you anytime you always have changes of shading either in 0 to in basically even mounts 0, 2, 4, 6, and 8. But if you try to change multiple times, that's not going to work, right? Because as an example, say it went pink, orange, and then pink here. The problem is, how do you orthogonally connect the pink regions on the edges without breaking apart the orange regions? The answer is you can't. Same with the oranges. You can't change that either. So this is pink. So we have a change here, definitely, because this 2x2 area cannot be all orange. Hmm. Um. Hmm. Um. Hmm. Um. We know both of these. Actually, these have to be the same shade, and this has to be the same color too. If it's not, then you would have that deadly pattern of two digits that are the same diagonal being different colors, or being the same color, across the diagonals being the other color. So this must be one shading. Okay, so why don't we make this yellow and green then? We're going to make this specifically yellow and green. This will make orange and pink. So these have to be one color. So one of these has to be pink at least. We don't have any guarantee with this. I'm not sure how that works. These are opposite digits. One has to be even, one has to be odd. We're not sure which. What else do we know? It's likely, again, that the anti-parity line is on a diagonal. The thing, yeah, because is a line if it goes diagonally, if it goes like this? I don't think that forms a correct line, so I think it has to be a diagonal, right? Otherwise, a line doesn't work, right? It's not, well, it is technically a line if it does something like that, but that's usually a line implies it's basically a straight line through 2 points, right? And all the other examples of anti-parity lines have been diagonals that I've seen. So, anyways, so say we had anti-parity line here. Could that actually be the case? If this were yellow, one of these would be green, the other would be yellow. If this was anti-parity, you could not, these would have to be these would be one parity, these would be the other. So then it would have to swap here. So then this would be all yellow. And then we'd have green go all the way around here. If this were the anti-parity line. But then the problem is these would have to be different parities, which is not allowed. So this cannot be the anti-parity line. Therefore, it's likely that the anti-parity line is this way. And then these have to all be odd digits. Let's mark that actually as red. Could that work? So this would be odd, which would make this even. These two would match these two. So these would have to be different parities than these two. Which means these would be green, and this would have to be yellow here. So these would all be yellow. You'd have green having to go up to there. This would be yellow. You'd have green here. This would have to be odd, so then these would be even. And okay, so then this would have to be 2 and 8. And this would have to be 4 and 6. And then it would have to swap here. Because there's no way that this could be 4 and 6 could not, it has to be next to 1 or 9, if that's the case. So then these would be even. Yellow would be blue, and then green would have to be red. So then this would be red. This would be red because of the 2x2 area can't be all red. Okay, so then this would be that way. This would be here. This has to be blue because of the 2x2 area that's all red. So we have boundary here, boundary here. But that doesn't really affect anything except for Whisper 5 lines. So this can't be 2 or 8. This can't be 2 or 8. This is even. This has to be 2 or 8 in that instance. This is 4 or 6. So this has to be red. Because 4 and 6 cannot be next to 2 and 8. So this must be red here, which means this is a 2x2 area that's all red. So this must be blue here. Therefore, this is 1 or 9. This is 1379, 1379 here. These are all odd digits. So then this must be red on this line. This is red, that's blue. So this is 4 or 6 next to 1 or 9 here. Okay. We have, this is red. These are blue across this diagonal. So therefore this orange must be blue. Therefore this can't be pink, or this pink is red. We have a 2x2 area that's all blue, so this can't be blue, that's red. We have a 2x2 area that's all red, so this can't be red there, it's blue. So this is blue, this is red here. Since this is, well, we don't know if it's odd or even, actually. This has to go out somewhere. This is 137 or 9 also. The remaining digits here, one of them has to be 4 or 6, and we have 5, and the other is 137 or 9. Cannot be 2, 8. Okay. This is also 137 or 9. These have to be odd digits. Oh, that's interesting. So this is odd. These are all odd digits, right? So that you can match 1, 3, 5, 7, 9. Obviously, this cannot be 5. So that you can match the parities along this, right? So these two, this is odd, which forces this to be even across the mirror. This is odd, so this must be even here. So this is even across the mirror. 1, 2, 3, 1, 2, 3. This is odd, so this must be even across the mirror. So this is even, even, even. That makes this odd there. Because it has to be blue for the Whisper, on the Whisper 5 line. So this has to be 2 or 8 because it cannot be 4 or 6. That means this eliminates 2 and 8 there. It's 4 or 6. One of these is 5. So one of these is 5, which is odd. The other one's odd, and the other one's even. So we have 2 evens and 2 odds. Which means this has to be even here. Because it can't have both evens be here. So if you had odd, odd here, that would force us to be even, even, but we have too many evens in this box because there are no repeats. So therefore, this must be even here. Cannot be 2 or 8 because these are different 2 or 8. So this is 4 or 6. So this is even, which forces this not to be even. This is odd. And then one of these is even, one of these is odd. Same with this, right? 1, 3, 5, 7, 9. If they're consecutive, that has to be even. If it's a 1 to 2 ratio, it must be even also, right? So this is always going to be 2, 4, 6, or 8, which means this has to be across the parity line odd, 1, 3, 5, 7, 9. And this across the parity line is odd, 1, 3, 5, 7, 9. This is 4 or 6, which means this is odd, 1, 3, 5, 7, 9. This has a diagonal which is all blue, so therefore this must be blue, because if this is red, red, that would give us the deadly pattern for yin-yang shading. This connects this way or this way, we don't know. We don't have any information about non-Whisper 5 lines that are colored. This could be even. We don't know. Only interesting. What you cannot have is 3 even numbers here. Right? If you try to have 3 even numbers here, you'd have to have 2, 8 next to a 4 or 6, which is impossible. So, and because we already have 4 odd digits in row 7, you can only have 1 odd digit here. So you have to have 2 even digits here, which means this must be even. So this must be even, which makes this odd to be on the parity. This is comparable to this set here. And we have 2 evens and 1 odd. Well, the only way... You have 2 evens and 1 odd. If we try to have an odd here... So, if this were odd, this would be even, and you could have 1 even and 2 odds. That works perfectly fine. Oh, this makes up a perfect set here. Interesting. So this is 1 even and 2 odds. Well, there's no way you can have odd and odd next to each other, so this must be even, and this is 2 or 8. And this has to be 1, 3, 5, 7, 9 to be the odd. So this can't be even. It has to be odd. So it's 1, 3, 7, 9. This is 2, 4, 6, 8 here. So since this is 2, 4, 6, 8, we are guaranteed that this has to have a 1 to 2 ratio here. It can't be consecutive with each other. So it's either 4 with 2 or 8 here. Well, that means this has to be 6 in one of these. So 1 has to be next to it. So this must be 1 with 6 and 8 there, which eliminates 1. This can't be 1. This becomes 9, and that must be next to 4. This can't be 1 or 7 or 9, so that's 3. So therefore, that leaves this as 5 or 7, and this as 5 or 7. And this becomes a 2-4 pair. 2 and 4 could only be in consecutive with 1, 3, or 5, or in a 1 and 2 ratio with 1. So this is 3 and 4 here, which eliminate. This can't be 3 or 9 here. No 3 or 4 or 9 remaining in this cage because we don't have repeats again. This is 3 and 9. This is 1, so these must be high digits. This 1 eliminates 1 from being there because of 1 in the row. So this is 6, 7, 8, 9, 6, 7, 8, 9. We're not sure which. Huh. This 9 eliminates 9 from the rest of the column. 3 eliminates 3 from being there. Hmm. Hmm. This is boundary here. And we have boundary here also. Oh, this is even, so this must be blue. This is odd, so it must be red. This is even, must be blue. So this is red, red, so therefore this must be red here to form a yin-yang. This is boundary here. So this cannot be 6 or 8, it's 7 or 9. Okay. Hmm. That must make this interesting. This either connects this way or this way. Um. Hmm. Mm, 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 mm. We know this can't be two evens because it would have to be 2 and 8 next to each other if it were. So one of these has to be red. We don't know if both have to be red. Um. Okay, this can't be blue. If this were blue, I have a diagonal of all blue, and this would be the red, so therefore this would have to be blue, but then we'd have a 2x2 area that's all blue. So this has to be red also. So this can't be 6 or 8, it's 7 or 9, which eliminates 7 and 9 in the rest of the column. So if this is red, we would have to have a 3 there. So this is red here. We don't know anything else about that. Huh. We don't know if this is red or blue because it doesn't matter. unless it's on the Whisper 5 line. Hmm. Only one of these can be red at most. One of them has to be blue, guaranteed. So these are 7, 9, 7, 9. So this must be even here. So this is 2, 4, 6, 8 to mirror. Well, we have a 2, 4, 6, 8 quadruplet in column 2. Right, so the rest of the digits in that column are odd digits. 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, which means along this it has to be even. So this has to be a 6 here. So this is 6, which means this can't be 6. So this has to be 4 or 6 here, which eliminates 4 and 6 in the rest of the row. So this can't be 4 or 6 here. This is 2 or 8. 2 can be next to only 1. 8 can be next to 7 or 9. These have to be even and must be a 2-8 pair. Okay. We have all the odd digits here. We don't know which one's which, though. So one of these must be even. Can you have both be even? That would mean both of these would be odd, which is not allowed because to be consecutive, you have to have one odd and one even. To be in a 1-to-2 ratio, one of them is guaranteed to be even. So this must be odd and even, which means there's a 3 here and it has to be with 8. And that means this can't be 3, so this is 5. So then this has to be one odd, one even here. And this is 3 evens anyways. Right, so this... Okay, well, yeah. We were thinking if this was 2 evens, this could be 2 odds. But this can't be 2 evens? Right, if this is 2 evens, this becomes 2 odds, and that's not going to be able to form any relationship. Right? It can't be consecutive, they can't be in a 1-to-2 ratio. So this is odd and even, which means the rest of the digits in row 5 are all odd. It's 1, 3, 7, 9. This can't be 3 because of 3 in the column. This can't be 9. So we have all the odd digits now in column 9. So this must be 2, 6, and 8, 2, 6, and 8, 2, 6, and 8. Since this is odd, that mirrored must be even, and it must be 2 or 8. It cannot be 8, so it must be 2. Because this is 3 and 8 to be next to each other on the Whisper 5 line. 2 eliminates 2 here, so that's 8, which means this cannot be 1. This is 7 or 9. This 8 eliminates 8 in the rest of the cage, so that can't be 8. This is 2 or 6. Therefore, the remaining digits in column 5 have to be 4 and 6. Because we have all the odd digits accounted for. That means this must be odd. 1, 3, 7, or 9. We have all the odd digits, and we have 1, 3, 7, and 9 as a quadruplet in column 1, which eliminates 1, 3, 7, 9 in the rest of the column. So this can't be 1, 3, 7, or 9. It's 5, which eliminates 5 in the rest of the row. And the rest are 2, 4 are even digits. 2, 4, 6, 8. That corresponds to odd digits here. 1, 3, 5, 7, 9. So this is even, even, even. If these... You could have both odds here, and these were both evens. That is possible. This 8 eliminates 8 here, so this is 2, which makes this 8, which cannot be next to 7, so it's next to 1, which means this cannot be 1 here. This is 5 and 7 as a pair. 1 eliminates 1 here, so this can't be 1. This is 3. This can't be 1 or 3. It's 7 or 9 here. Okay. I don't know if this is a boundary or not. Probably. Well, if it is anything, it has to be blue, but it's not right now. 3 can be next to either 2 or 4. That's fine. Okay. This is 4 or 6. This is odd. We have 2, 6, and 8. Remaining digits in row 1 have to be all odd. 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. That means we have 4 odd digits. That's not helpful. This can never be 5. Because if it were 5, what relationship is it going to have with 2 or 8? There is none, right? So it's either 1, 2, 3 or 7, 8, and 9. It cannot be 7, 8, and 9 because that would eliminate all possibilities for this cell. So it must be 1, 2, 3. So this is 2. That eliminates 1, 2, and 3 in the rest of the column. So this can't be 1, 3. This becomes 5, 7, 9. Since this is 5, 7, 9, that eliminates 5, 7, 9 in the rest of the cage. So this can't be 5, 7, 9. This is 1, which is next to 6 out of 1 out of 4 and 6. 6 eliminates 6 here, so this is 4. No 1 is available here or here because of 1 in the row. This also eliminates 1 being here and 1 being here. So to be next to each other, this has to be a 3, 9 pair. 2 eliminates 2 here, so this is 8, which makes this 2. This 3, 9 pair eliminates 3 and 9 in the rest of the box, so this has to be 8 next to 1. Or, sorry, cage. 1 eliminates, that has to be next to 9 out of 3 or 9, so this is 9, that's 3, this is 7. So this can't be 9, so that makes this 7 here, so no 7 remaining. This can't be 1, 3, or 9. It has to be 5 or 7. Cannot be 7 because of 7 in the row, so this must be 5. 1 eliminates 1 in the rest of the row, so no 1 here, no 1 here, no 1 here. This can't be 7 remaining in the rest of the row, no 2 remaining in the rest of the row because of the 2 and the 7 in the row. This can't be 1 or 5, no 1 or 5, no 3. So this becomes 7 and 9 here. 2 eliminates 2 here. So this is 4, which makes this 2. That eliminates 2 here and here in the column. 4 eliminates 4 here in the row, the column. So that's 8, which eliminates 8 in the row. So, remaining even digit is 4 and 6 here. The remaining odd digit is 1, 3, or 9. This can't be 1 here. Actually, none of these could be 1 because they have to be, and none of these could be 9. So this has to be 3 here, with 4 or 6 to be in a 1-to-2 ratio, or to be consecutive. So that eliminates 3 here, so this is 1, which eliminates 1 here, so it's 9. This can no longer be 1. This 7 eliminates 7 in the rest of the cage. This becomes a 3-5 pair, which eliminates 3-5 in the rest of the column. So this can't be 5. This is 7. This 3-5 and 7 eliminates 3-5, 7 in the rest of the cage. So this is 9, which eliminates 9 in the rest of the row. And the rest of the column. 5 here eliminates 5 in the row, so this must be 3, which makes this 5, which eliminates 5 here. This 4 eliminates 4 in the rest of the column, so this is 6. This 7 eliminates 7 in the rest of the row, so no 7 here, no 7 here. Okay. This 1 eliminates 1 here, so it's 3 or 7. What are the remaining digits in row 2? We have 1, 2, and 4. Well, this can't be 4. It's 1 or 2. And it has to be next to a 7 then. So this is 7. This can't be 7. That's 5. No 1 here. 2 eliminates 2 here, so this is 6. 3 eliminates 3 here, so it's 8 and 3. So this is blue, and this must be red. We also knew there was a boundary there, so that's there. 6 eliminates 6 here, so that's 4. So this is 3. The anti-parity across it must be even, so this is 4, 6, which forces this to be 3 there. No 3. This 3 eliminates 3 here, so it's 1, which makes this not 1. That's 3. So this can't be 1 or 3 here in the row. No, 6 eliminates 6 in the column. 3, 4, 6. What digits can be next to this? It cannot be 2, 3, or 4. It has to be 1. So this is odd. And must be red. Well, we have a diagonal that's all red. And this is already blue, so this must be red here also. This is 3 reds in 2x2 area, so this must be blue. This is a blue diagonal, so this must connect that way and be blue. This has to be 7 or 9, which eliminates 7, and we have a 7-9 pair in row 4, which eliminates 7 and 9 in the rest of the row. So this has to be 5, which eliminates 5 here in the column. Also, since this is odd, this must be even. So we have 2, 4, 6, 8. We have all 4 evens in column 6, which eliminates 2, 4, 6, 8 in the rest of the column. So this can't be 2, 4, 6, 8. It's 1. So this must be red as the color on the green line. We have a 2x2 that's all red. So this must be blue. We have a diagonal that's red. So this must be red. Blue has to orthogonally connect, so these must be blue. Blue has to orthogonally connect, so that must be blue. This is diagonal, that's red, so this cannot be blue. This has to be red. Boundary. Blue has to orthogonally connect, so it must connect to here. Therefore, this is not, this is a boundary, this is a boundary. These are boundaries, these are boundaries. Blue has to orthogonally connect. This is blue, so this must be red here, which makes this blue here. Blue has to orthogonally connect, and it must orthogonally connect again. This is a 2x2 area that is all blue. So this is a diagonal that's blue, so this can't be red, because this has to be red here because of the 2x2 area. This is a diagonal that's all red, so this must be red there. Blue has to orthogonally connect, so it must connect there, and it must connect there. And we have a diagonal that's orthogonally red, and this must connect, so this has to be red. So these are the boundaries of the yin-yang shading. Remaining digits in row 3 are 5 and 9. This can't be 5 because of 5 in the column, so this is 9, that's 5. 9 has to be opposite an even number. So this is 2, 4, 6. And this is 2, 4, 6. So this has to be a 1 to 2 ratio here, so neither of these can be 6. It has to be 4 with 1 of 2 or 8. This 3 eliminates 3 here. So we have a 2, 4, 8 triplet in row 6, which eliminates 2, 4, 8 in the rest of the row. This can't be 4 or 8. It's 6, which means this is 4. This is 8. 4 eliminates 4 here, so it's 6. Oh, we already knew that. Okay, well. Anyways, we have a 7, 9 pair in row 6, which eliminates 7, 9 in the rest of the row. And this can't be 1 because of 1 in the column, so this is 5. This one eliminates 1 here, so it's 2 and 4. Across the diagonal must be an odd digit. It cannot be 3, 5, 7, or 9, so this has to be 1. That leaves this digit we have as a 4. 4 eliminates 4 in the rest of the row. Also, we have an 8 in the row, so that 8 eliminates 8 here, so this is 2, which makes this 8. 2 eliminates 2 here, so it's 6. 8 eliminates 8 in the rest of the row, so this is a 2, 4 pair. 5 eliminates 5 in the column. We have a 3, 9 pair in row 9, so this can't be 9. This is 5, which makes this 7, which makes that 9, which makes this not 9, so it's 7, which makes this 9, which makes that 7, which makes that 9, which makes that 7. That 7 eliminates 7 here, so it's 3 and 7. 3 eliminates 3 in the column, so that's 9 and 3. Okay. Do we have any disambiguators from this? Oh, this is 2, 4 as a pair, and they have a cage, so this can't be 4. This is 6, which makes this 4, which makes that 2, which makes that 4, which makes that 2, which makes that 4. 6 eliminates 6 here, so it's 8. 8 eliminates 8 here, so it's 2, which makes that 8, and that a 6. And that's the solution to this puzzle. I wish they had designated that a diagonal was the anti-parity line. It's kind of confusing if you haven't, particularly if you haven't actually. I've never actually done an anti-parity line, so I didn't really understand what it was. But then I just did a search to try to figure out what that was. Yeah, so I wish they had designated that one of the diagonals was anti-parity line. Because otherwise I think you get just kind of stuck because you don't know the rule set, right? So, but yeah, still pretty cool puzzle. Interesting way that it worked. Yeah, I guess that in the end we didn't have. Yeah, this would have to be gray, right? It's a black hole, right? So it's not one of the colors. But all the reds are orthogonally connected, all the blues are orthogonally connected, and this cannot be blue or red, because then you'd have a 2x2 area that's all red, or the blue would not be orthogonally connected. But yeah, pretty interesting puzzle. Very unique rule sets. I haven't run into many of them at all. Like, particularly the yin-yang with colors, even colors being one color and odd colors being another on the Whisper 5 lines. We have run into the gray squares, or the gray dots, but not too often. So that was interesting. And then the cages, and then obviously the anti-parity line. I've never run into that either. So that was interesting. And then the cages being only used for no repeats, anti-repeat, was very interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.